Okay, next we'll look at the operations named conjunction and disjunction. Now, clearly, most of you will know these with their more famous names and or. So conjunction is logical and disjunction is or, right? So how do we define them? Well, first of all, these are binary operations. As you recall, negation is a unary operator, which means it requires or it accepts a single input. As opposed to that, conjunction and disjunction requires or accepts two inputs. Okay, two propositions are inputs to these operations. Logical AND or conjunction is a binary operation which produces an output of true when two inputs are both true and an output of false otherwise. Okay, so the only way an AND operator produces an outcome of true is that both inputs are true. And as opposed to that, when it comes to disjunction or logical OR, it's the binary operation which produces an output of false when both inputs are false and true otherwise. Okay. So you also see the representations here. This is conjunction P and Q, and this is disjunction P or Q. So this is P and Q, and this is P or Q. That's how we read this. Now, we have the truth tables here. Now, I didn't describe or define what a truth table is. I think it's self-explanatory, even if you didn't encounter it before. On the left-hand side, you have, well, we talked about this very briefly in negation. Now, on the left-hand side, you have the input and all possible input values here. And on the right-hand side, you have the outputs. And here it's the same, only this time, disjunction and conjunction, they expect two inputs each. Therefore, the number of input combinations are now, instead of two, we have four possible inputs: false, 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 true, true, false, and true, true. Okay, so if you recall the definitions here, conjunction is going to produce a true value only when both inputs are true and false otherwise. On the other hand, disjunction is going to produce an output of false only when both inputs are false and true otherwise. And we can also use multiple operations to combine propositions when we have compound propositions, right? It's possible to combine logical operators and to obtain compound propositions. An example is given here: P or Q and R. So P, Q, and R are propositions here. And we have a compound proposition. We first, well, obviously, as with any mathematical statement, you go into the parentheses first. So you just do P or Q first, and then whatever the result, you end it with R. So now look at this truth table. Now it has become bigger because now I have three variables to describe this compound proposition: P, Q, and R. That means I have 8 possible different input combinations. Now, obviously, that's not a coincidence that when I have just a single input, it's 2, because just true and false. When I have 2 inputs, it's 4. And I have 3 inputs, it's 8. Obviously, that's not a coincidence. And the number of possible input combinations is a power of 2 to the power n, where n is the number of variables, let's say, or inputs. Now here, since we have 3 inputs, P, Q, and R, or you can treat this, since this is a compound proposition, you can see P, Q, and R as just propositions that make up this compound proposition, or variables. Since we have 3 of them, 2 to the power 3, we have 8 possible combinations here. Now, as I said, you look at the parentheses first. So you you find the value of P or Q from the definition of or we have just seen, and then you take that and you AND it with or, and the outcome is listed here. So this is the value that this compound proposition takes depending on whatever the input combination is given. Right, so operator precedence is, as I said, parentheses first, important, and negation second. Well, we do not have a negation in this example, but after the parentheses, you go for the negation, and the rest last, right? So negation as the unary operator takes precedence over the binary operators. Now, what about the precedence among and or? Now, I can form a duality between this and the usual addition and multiplication with numbers. So, for instance, if I write 3 times 5 plus 2, how do you read this, or how do you compute this? Clearly, you just compute the multiplication first. Why is that? Because that's the convention we have agreed upon. That's the only reason, right? If we had agreed on, okay, in such a case, we will do the addition first. That would have been the convention, which we didn't really prefer. We preferred giving precedence to multiplication over addition. Now, when it comes to logic, especially propositional logic, for instance, if I write this without parentheses, I get P or Q and or. Right. Now, in this form, very strictly speaking, this is ambiguous because we don't really have a certain precedence among and or, but we have a convention, usually similar to multiplication. We sometimes prefer to give precedence to and, right? So we will just take this as do this first and then apply the or here. But that is not universally agreed upon. It's not a mathematical fact that we do this. Therefore, do not really trust on that. And in doubt, most certainly in this course, use parentheses to avoid ambiguity. Okay, so you have the option to have this or this, and these are, well, I didn't check if it is the case with these two, but usually when you have such an expression, it will be different propositions. Therefore, you have to be careful about operator precedence. And when it comes to and ors together, usually resort to using parentheses to avoid any ambiguity.